students, I am Dilip Udani, Assistant Professor at LJ Institute of Engineering and Technology. Today in Improper Integrals, I will teach you new topic, that is beta and gamma functions and their properties. So let's start. So first of all, we will see what is gamma function. Gamma function is defined by the improper integral integration from 0 to infinite e raised to minus x, x raised to n minus 1 dx, where n is greater than 0 and is denoted by this symbol, and this is read as gamma n. Hence, gamma n, that is equals to integration from 0 to infinite e raised to minus x, x raised to n minus 1 dx, where n is greater than 0. So this is how we define gamma function. Now we have alternate form of gamma function, and that is gamma n, that is equals to 2 times integration from 0 to infinite e raised to minus x square x raised to 2n minus 1 dx. Now we will see properties of gamma function. Property number 1, gamma n plus 1, that is equals to n into gamma n. If you write down, say gamma 6, so gamma 6, that will be phi into gamma phi in this way. You have to note down this point. Gamma n plus 1, that is equals to n factorial if n is a positive integer. For example, gamma 6, that is equals to 5 factorial. Now property number 2, value of gamma 1 by 2, that is equals to root pi. Now property number 3, gamma n into gamma 1 minus n, that is equals to pi upon sine n pi. Now we will see one example related to gamma function. Evaluate integration from 0 to infinite e raised to minus root x, x raised to 1 upon 4 dx. So here is the solution. Let this root x equals to t, because we are going to convert this integration in the form of gamma function. So that's why we have to take root x equals to t. If root x equals to t, then definitely we will be having x equals to t square, as squaring both sides. Now we will find out differentiation of x equals to t square. So it is dx, that is equals to, and for t square it is 2t dt. Now we will change this limit. When x equals to 0, if you will put down the value of x equals to 0 over here, we will be having the value of t. So value of t equals to 0. So when x equals to 0, we have t equals to 0. Now when x equals to infinite, if you will replace x by infinite over here, so square root of infinite, that is again infinite. So when x equals to infinite, we have t equals to infinite. Now the given integration, that is integration from 0 to infinite e raised to minus root x, x raised to 1 upon 4 dx, that is equals to integration from 0 to infinite e raised to minus root x, that is equals to t, and x, that is equals to t square, and replacing x by t square, so we have t square the whole raised to 1 by 4, and replacing dx by 2t dt. Now we will simplify this result. So this is equals to, this 2 will be as it is, integration from 0 to infinite e raised to minus t. Now multiplying 2 by 1 by 4, so it will become t raised to 1 by 2, and t raised to 1 by 2 multiplied by t raised to 1, so it will become t raised to 3 by 2 dt. Now we will write down t raised to 3 by 2 as t raised to 5 by 2 minus 1. By doing so, this integration will become gamma 5 by 2 and this 2 will be as it is. Now we will evaluate the value of gamma 5 by 2 by applying the property gamma n plus 1, that is equals to n into gamma n. So this is equals to gamma 5 by 2 will become 3 by 2 into gamma 3 by 2. And gamma 3 by 2 will become 1 by 2 into gamma 1 by 2. Now we will simplify this result. Now this 3 will be as it is, 2 will cancel out and this one 2 will be as it is, and value of gamma 1 by 2, that is equals to root pi. So 3 by 2 root pi, this is the answer of given this integration. Now we will see what is beta function. Beta function, beta m comma n is defined by beta m comma n, that is equals to integration from 0 to 1 x raised to m minus 1 minus x the whole raised to n minus 1 dx, where m is greater than 0 and n is also greater than 0. So this is how we define beta m comma n. Now we will see trigonometric form of beta function, and that is beta mn, that is equals to 2 times integration from 0 to pi by 2 sin raised to 2m minus 1x cos raised to 2n minus 1x dx. Now we will see properties of beta function. Property number 1, that is called symmetry. So by the property of symmetry we have beta mn, that is equals to beta nm. Now we have property number 2, that is relation between beta and gamma functions, and that is this one, beta mn, that is equals to gamma m into gamma n upon gamma m plus n. So this is the relation between beta and gamma function. Now this is property number 3, which is called duplication formula, and this is the duplication formula, gamma m into gamma n plus 1 by 2, that is equals to root pi into gamma 2m upon 2 raised to 2m minus 1. Now we will see one example related to beta function. Evaluate integration from 0 to 1 x cube 1 minus root x the whole raised to 5 dx. So here is the solution. Let root x equals to t. Now squaring both sides, we have x equals to t square. Now we will write down x equals to t square in differential form. So we have dx equals to 2t dt. Now when this x equals to 0, so replacing x by 0 and root x equals to t, we have value of t, that is equals to 0. Now when x equals to 1, replacing x by 1 and root x equals to t, so we have t equals to square root of 1, so that is 1. So for x equals to 0, t equals to 0, and for x equals to 1, t equals to 1. Therefore the given integration, that is integration from 0 to 1 x cube 1 minus root x the whole raised to 5 dx, that is equals to integration from 0 to 1, then after replacing x by t square, so x cube will become t raised to 6. Then after 1 minus replacing root x by t, so it is 1 minus t the whole raised to 5, and replacing dx by 2t dt. Now we will multiply t raised to 6 by t raised to 1, so it will become t raised to 7, and this 2 and 1 minus t the whole raised to 5 will be as it is. So this is equals to 2 times integration from 0 to 1 t raised to 7 1 minus t raised to 5 dt. Now just write down t raised to 7 as t raised to 8 minus 1. And 1 minus t the whole raised to 5 as 1 minus t the whole raised to 6 minus 1. So by doing so, this whole integration will become beta 8 comma 6, and this 2 will be as it is. Now we will evaluate the value of beta 8 comma 6 using the relationship between the beta and gamma function. Beta mn, that is equals to gamma m into gamma n upon gamma m plus n. So this is equals to 2. This is beta 8 comma 6. So this is equals to gamma 8 gamma 6 upon gamma 8 plus 6. And 8 plus 6 is 14, so it is gamma 14. And this 2 will be as it is. Now gamma 8, according to the formula gamma n plus 1, that is equals to n factorial. So gamma 8 is 7 factorial, similarly gamma 6 is 5 factorial, and similarly gamma 14 is 13 factorial. Now we will simplify this result. So this is equals to 1 upon 5148. So this is the answer of this given integration. So in today's lecture we have seen what is gamma and beta functions. We have gone through its properties, and we have gone through 2 examples related to this topic. Thank you for watching this video. I will see you in the next lecture.